No matter what business you're in, digital transformation never stops. At Verizon, we keep companies ready for what's next. We weave security into their business, virtualize their operations, and build AI customer experiences. We also keep them ready for the next big opportunity, like 5G. Almost all of the Fortune 500 partner with us. When it comes to digital transformation, we're here and we're ready.
Hello and welcome to Effective Supply Chain Monitoring. If you're joining us live, our speaker is in the Slido discussion answering your questions right now. For audio and video issues, please click the technical support button below. I'd now like to turn it over to our speaker, Michael Angelo, for the presentation.
Thank you, Ali. I would like to talk to you today about effective software supply chain monitoring. It's a subject that I've been working on for the past 10 years, and it came about rather strangely to begin with. With that in mind, let's talk about the agenda. I'll give you an outline of the problem. We'll talk about the data collection strategy, how you can actually go and address some of these issues and get things moving, how you can analyze it, and then I'll give you some suggestions for implementation. One thing to point out, I will show you some screenshots. These are from a program I wrote internally. There's no way for me to get you a copy of it, but the better part of it is you can look at what I'm doing and understand how you might want to implement it and improve on what I did. Clearly, what I've been doing over 10 years has been hack a little bit here and push a little bit there. So let's talk about the real problem. When we look at our companies, we think about security, and we've looked at everything we could possibly do with respect to security. I mean, we've trained our users, we've scanned our systems, we've configured them, and we're secure, right? Well, consider our environment as though it were a bottle of water. We know what's in water, 2 hydrogen, 1 oxygen. Everyone who's did any chemistry in high school or junior high even knows that. But then we have a new water that gets released, and it's improved. It's got things in it like salt and magnesium sulfate. And if you have them in small quantities, you're okay. But if you have them in large quantities, they can really upset your stomach. Now, consider the software in your environment. When you add new software, does it impact your security model? What if we change the usage model for that software? How does that really impact you? Does it change your security? Does it weaken it? When we look at water as an example, we pay attention to where it comes from, okay? And in reality, in today's world, it's not really the overall product that we care about. It's not the product we care about. It's not the origin. It doesn't really matter if it's commercial software or homegrown or open source. What matters is what's in the software itself. So our first problem is with our environment. How do we know what's in our environment? When we look at our systems, do we know actually every product that has been added in there, every download that's been added in there? Or do we think we know? And then the question is, what vulnerabilities do they actually have in those products? Are there things we can track that tell us what's installed in our environment? I mean, can we monitor those applications via the National Vulnerability Database? We can go out, we can buy some tools to solve the problem, to keep track of what's in our environment, but we're going to pay big dollars for those. And they're going to do binary analyses. And I don't know about y'all, but my budget hasn't grown over the past year. So I could do it myself, or we can do it ourselves. And that's what I want to talk to you about, is how you can do it yourself and what pieces you actually can deploy in your infrastructure. So The first piece is we can identify the products in our environment. We could do it manually. We could write some software to look for copyright statements and trademarks and all the version information in the product headers. We can look for license files associated with those products, and we can even generate hashes of everything on the computer and then look them up in a national database somewhere. So assume we can identify all the components in our infrastructure. The next question is, what's the real product associated with that component? Where did it come from? What version is it? I don't know about you, but when I look at my system, I have got 4 different copies of a component and 5 different versions. Okay, so 4 different versions. The question is, can I associate the versions of those components back to a product? And when I do, can I look and find the vulnerabilities associated with them? Well, a few years back, the National Vulnerability Database came out, and now we can look at products and we can say, this product has these vulnerabilities, and we can push a vendor to go and provide a update to the product or a solution, and it generally works well. And you can see that over the past, since we've been doing it, we're finding more and more vulnerabilities, and we're declaring those vulnerabilities. So as popularity and analysis processes have taken off, we can see that this is still increasing. And then if we know the applications in our environment and we know their vulnerabilities, we should be able to cut this back down to 0, but maybe not. If you think about it, there are currently 324 open SSL vulnerabilities. And when you look on the list, you'll see there are 3,208 products with SSL as components. Remember, most software is written for functionality, not necessarily security. And we may include components that are vulnerable, but how do we really know what components are vulnerable? Think of it this way also. When we get a component that's really vulnerable, it can be prevalent throughout our entire infrastructure and the world. So in 2014, sorry for the old statistics, it was said that 2/3 of the web servers used OpenSSL to secure their communications. If I looked on March 1st, there are 1,263,000,000 sites on the internet, or sites, domain sites, and they're pretty much all using OpenSSL. And even if we just limit it to the number of web-facing computers, there's almost 10 million web-facing computers, all of which are running OpenSSL. So having 3,208 different programs that have vulnerabilities and 324 vulnerabilities available to them makes this number non-tenable for us to continue to survive. So how do we find the components in the product? So if I'm using OpenSSL and I've got a program like Tomcat or something else and OpenSSL is embedded in it, how do I find out what products actually have an OpenSSL? Well, I can look at the install list, and sometimes that works, but it usually doesn't drill down all the way. There are some free tools like the OWASP dependency checker, which will let you do that. But it, again, doesn't do everything. So you could build your own tool. NIST has a software reference library that has hashes for hundreds of thousands of different products. And there are already some tools out there that you can actually go and get to do the lookups based on the hashes. So that makes it easier to say this component is probably associated with this application. I've also taken the liberty on the slides to stick all of the references to where you can find stuff so that if you want to go back and try and start doing this on your own, you at least can start from there rather than having to go and hunt and find it. Okay, so if you're developing software on your own, then it's relatively easy because you're going to require your teams to declare what third-party components are in there to begin with. You want to do this in general so that you can make sure that you're not violating any software licenses or doing anything that's going to get you in trouble with someone's copyright. So you could be required to declare what the components are, or you could go out and get automation tools as applicable. So a WASP dependency checker, for example, is a good tool to go and use to run and see what third-party components are there, and it'll also give you some of the vulnerabilities. As far as external software, you should be able to start asking for a build of materials. And as we move forward in time, there are standards that have been proposed and that are being adopted to actually go and do these builds of materials. So that sort of solves our problem with supply chain, right? Well, maybe not. The next problem with the components is we need a way to track all of the vulnerabilities after the tools are deployed. So, when we're looking at putting the product out on the system, we can go and we can look at the tools and we can look at the vulnerabilities and we can go and look up them at that point. But what if a new vulnerability is released for a component that's embedded in a product? So we really need a tool that will cross-reference the software that's on the system or in the infrastructure to the vulnerabilities in the CVE database and raise the awareness. It should provide sufficient information to enable you to test or ask about the potential security vulnerabilities from your vendors or from the people who wrote the software in your own infrastructure. The rest of this presentation, we're going to cover the lessons I've learned and the gotchas I've had in developing a local tool in my infrastructure to identify and bring the awareness of these components and these vulnerabilities to people in my organization. So the first thing you're going to want to do is you're going to want to define a local database. It's very important you do this because you're going to be dealing with a lot of data. If you look at how many pieces of applications or how many applications are in your infrastructure, and if each application has 20 or 30 subcomponents, you're going to want to track those. So you're going to want to develop a local database. The stuff that I've portrayed here is stuff that I think helps. Of course, you're going to have the ID of the component. You're going to have pointers to the components and subcomponents. You're going to have copyright. You may want to put some other things in there, like the license reference. Is this an open as a LGPL, or is it a licensed software component for a library, et cetera? So you're going to want to track that also, but I'm kind of glossing over that because there's so many different things you can put there. You'll also want to have CVEs with the component list. So, CVE1 has these 5 versions of this software in it. And you're going to want to make sure that you've enumerated them, because just because you've got a version of software, a software package associated with your product, doesn't mean that that version is really going to be relevant for your infrastructure. What would a database be without relationships? One of the things I found early on was that you'll wind up with nested relationships. So you might have product one. Product one will have component 2 in it, and component 2 might have component 3 in it, and component 3 might have component 4 in it. So you'll want to know that so that as you're looking at your product list, you'll be able to say, oh, 3 or 4 levels down, we've identified these vulnerabilities. And you can go back to your vendor and say, are you impacted by this? 9 times out of 10, the vendors aren't, but it's always good to ask that question. In this case, I've just shown you 2 levels down, the main product and then a subcomponent. And I'm showing you an entry into the CVE database. And basically what we have is we've got the CVE number, and then we've got a component ID hidden in a table so that we can cross-reference back to the main CVE database. So if you look at it on the left, your product components, your CVE components, and then the CVE itself. Very important to get the link list of, or the link of the IDs in there properly and the child components properly, because if you don't, then things really get confused and you really haven't got what you thought you wanted. So Some other things to consider. Procedurally, there are too many new CVs released every day. I've got to admit that. Although there are a few days I see one or two, I normally see about 20 or 30 CVs every day. So you're going to want to load the CVs every day and look at those CVs to make sure that there's not something impacting your product. Now, the good news is this can be done relatively fast when you get the database in place, because you might have 20 CVs, but chances are you're not using any of the components in those CVs in your infrastructure. So it's a very fast run. The second thing you're going to want to do is you want to make sure that you're always reviewing the old products for new CVs every day. So you'll run your CV check, you'll get the new CVs, and then you want to run it against all the products in your environment out of your database. The next thing you're going to want to do is you're going to need to figure out how do you detect when a new product is on your system. Because just because you've got a old product doesn't mean that all the things are being identified. When you have a new product in the infrastructure, now all of a sudden you have to look and see, are there more vulnerabilities against that? Okay. And by the way, notification is really important. You want to notify someone if you see new products and components in your environment, preferably the person who's going to be tracking this stuff, preferably or maybe even the person who is going to be responsible for it. Okay, so you'll want to have a list of new products, a list of components, and then the CVs associated with any of those new products and or components. You're going to want to provide a triage mechanism to say, is this important? Isn't this important? Is there an issue here or not? Just because something has a CVE doesn't mean it's vulnerable. Keep that in mind. So when you kick off your program, you're always going to want to ask, do you want to update the CVE list? If they say no, then we'll bring you into another screen. But if they say yes, you're going to want to make sure that you've got certain features. For example, you want to make sure that you can specify the year. Just because you're in 2020 doesn't mean someone won't enter or update a vulnerability in 2019. And if that vulnerability from 2019 impacts your product, you've got an issue. Okay. You're going to want to keep track of how many vulnerabilities there are in the database. That's what this total current vulnerability is. And then you're going to want to also keep track of new vulnerabilities and updated vulnerabilities. And this stuff can take some time as you're downloading it. Well, download takes a few seconds, but as you're doing the analysis and dumping into your product, it's going to take a little bit of time. So you want to make sure that you've got some sort of measurement bar to track the progress. There have been a few times, because I've got my database across the network, that it's taken longer than I expected. And I was sitting there going, is this dead or isn't it dead? You will want to have a window on the bottom so you can see progress, display messages there, etc. When you're done with that, you would close this window, and it should bring you into the screen on the left, or something like the screen on the left. Okay. In this screen, you should be able to select any CVE, and it'll give you information about the CVE and the screen to the left, where it tells you what the vulnerability is and everything else. And you should be able to go and see what products in your environment, based on the CVE that you selected, are relevant. One thing that's important, because I'm not a SQL expert and I didn't want to grow up to be a SQL expert or an Access expert, I always displayed what the command string was that I was sending to the database so I could make sure it's accurate. There may be times, if you look to the second row from the bottom, the red arrow that's there, there may be times when you want to select a specific machine or groups of machines to scan and look to see if there's an issue. Very important. Now, because this code evolved over 10 years, I put a debug window in there, which is on the top. It's a debug flag. Basically says, okay, show me some hidden features. And that's what the screen to the right is. The screen to the right was an afterthought I had as I got used to doing this. Rather than just going through and looking at all the new CVEs manually, I want to see a bunch of things. So in this case, the first thing I wanted to see was what new products are in my infrastructure. Now, I wanted to set it up in such a way that I could go based on the portfolio, the machine portfolio, and then look at the products on that. So if I've got a HR group, I would have a portfolio for HR. And if I told it to scan the HR portfolio, it would automatically go and look all the way down. There were times when I just wanted to do one. There were times when I wanted to do just all the new stuff in the infrastructure. So I put a little flag there that says, show me everything that's new. And then I can run it. For various reasons, I decided don't let it automatically update the date. What I found happening was there were times when I found new machines or new products that I wanted to look at, and I wanted to go back, but if I exited the program, it updated the date, and then I had to edit the database, and that's not really something fun. So I force it to allow me to, or I created a button that says update the date on the new scan list. These are all simple things that, as you're doing the coding, you don't necessarily think about, but trust me, later on, having stuff like that, those features and functions can definitely save you a lot of time and aggravation. The next functionality was the daily test. Again, I want to start off with the portfolio, or I could say, show me all the portfolios. There are times when there are errors that will pop up, i.e., the NVD database doesn't always have all the data in it. I know you're shocked by this, but hey, it happens. So you're going to want to be able to go and tell it to ignore errors. You're going to tell it to go automatic. You may want to just look at one specific vulnerability in one specific application. So make sure you include buttons there to do that. Another cool feature that you're going to want to implement, because you've got all the data, is you're going to want to look up the CVE list by components. You're going to want to say, hey, I've got OpenSSL. Show me the list of all the CVEs associated with OpenSSL. And it'll actually dump the entire list by that component. Very useful. Of course, if you could do a list of CVEs and by component, you should also be able to list the components in a particular product. So you might sit there and say, oh, is OpenSSL 102J in this product? And you'll be able to just say, show me that and show me all the components in there. Of course, then you can have some fun and you can say, show me components and CVEs that match a specific product on a specific machine. And, the limitations are, the permutations are endless in terms of this. Okay, some cautions. Just because you find a vulnerability in a component doesn't mean it's meaningful. There are times I've seen vulnerabilities in Tomcat, and I look at the Tomcat code, and yeah, it's in Tomcat, but we're not even enabling that feature or functionality, so there's no way to get there from here. When you're doing this and you're looking at the CVEs and you're looking at the components, you should think about how you want to mark them. Are they relevant? Meaning someone's got to get an upgrade or an update, or you've got to figure out a way to fix it. Is it not relevant? Meaning it doesn't really impact us. There's no way to get it to impact us. And under investigation. Under investigation is probably the one that I look at the most often and I'm the most nervous about, because it means it may impact us or it doesn't, but we don't know. And anything we don't know is bad. Next year, of course, we're going to want to put mitigated or not mitigated or no mitigation necessary. So if it's not relevant, then of course no mitigation is necessary. If it's relevant and not mitigated, well, then you need to be looking at solving it. And if it was relevant and mitigated, then things are good and you can move on. There are issues with the vulnerability database. Sometimes you're going to get an error message that says this is lacking complete information. This happens from time to time. It's very frustrating, but plan on coding if the vulnerability database is not accurate or there's an issue with it. So to recap, applying this today, look at the resources that I talked about in the presentation. Look at the strategy for creating a tool that identifies components and software, or you should be able to go and look at some of the BOM, the Bill of Materials standards, and see if you can't use one of those. The tool you should create or can create should check against the CVEs, and it should enable you to triage and communicate potential issues with other people in your organization or your company or out there. So go out, spread the word. We've got these great databases. We've got this great technology that we should be utilizing to go and make our world better. And we really, really, really should be doing it. So just remember, don't poison your organization with new software or software that's not quite what you expect it to be, that has third-party components that may or may not have issues in it. Thank you.